You may have thought Tesla had reached the pinnacle of performance, longevity, and low-maintenance design, but hold on to your seats because they're about to take it up a notch. Elon Musk has just revealed their latest motor, and it's already causing a stir in the industry. Say hello to the hairpin motor, the revolutionary drive unit that's making electric vehicles even more competitive, not just with previous generations of EVs, but with combustion engines too. That's right, we're talking about a motor that promises to change the game forever, and we're here to show you why. So buckle up and get ready for a ride. We'll be diving deep into the benefits of the hairpin motor and why it's got everyone talking. Now, when it comes to Tesla, there's no denying that they've got their fair share of haters and lovers out there. But one thing we can all agree on is that they're making some serious strides in the world of electric vehicles. With their mission to cut costs and improve the environment, they're using software to model the best configuration and a unique design that involves welding without the use of rare earth minerals. This has resulted in a drivetrain consisting of a $1,000 motor and a $5,000 battery pack, making their mass-market vehicle not only feasible, but also high in gross margin. But what's more exciting is their new motor technology known as hairpin motors. It's like nothing we've seen before, and everything about it is more compact, lighter, and more evolved. One of the most impressive features of this engine is the hairpin motor fill factor. Basically, it means that the motor is up to a 0.7 fill factor compared to the 0.4 to 0.6 you'd find in conventional round wires. What this means is that the motor has better thermal performance and enables a highly automated manufacturing process. The new inverter design is a game changer. It's much more compact, with a cast-in-place high-voltage connector and a data connector. And when you remove the casted cover, you can see it for yourself. Tesla's also optimized the layout of the engine and even made the chiller assembly better. They've used a friction stir-welded piece to put it together, and the result is pretty impressive. Now, you might be wondering about the filter in the engine. It's no longer a spin-on or user-replaceable part, but that's because it doesn't really need to be replaced for the life of the car anyway. Unlike an internal combustion engine, this filter is just there to stop small wear and manufacturing debris, so it never needs to be changed. But let's back up a bit and talk about the basics of electric motors. In electric vehicles, the electricity supplied by the battery is converted into motion to move the wheels, and these new Tesla engines are taking that process to a whole new level. This is achieved by creating opposing magnetic fields in the stator and rotor. The push and pull force between these fields is what makes the rotor rotate. Now, in the stator, the magnetic field is generated by the electricity running through the copper windings. But in the rotor, there are two different ways to generate the magnetic force. In permanent magnet motors, magnets located in the rotor generate a permanent magnetic field. In induction motors, the rotor's magnetic field is induced using aluminum or copper bars. Since these bars are in the stator's magnetic field, an electrical current is induced in them, generating the rotor's magnetic field. And now that we've explained the basics, did you know that Tesla's been designing its own drive units since day one? When Tesla released their Model S back in 2012, they completely revolutionized the electric motor industry by bringing their drive unit in-house. That meant no more licensing technology from third parties. And let me tell you, their induction and permanent magnet motors are two of the most advanced and efficient electric motors on the market today. The induction motor was first developed by the legendary Nikola Tesla himself in the 1880s, and it remains one of the most widely used electric motors today. This motor uses a series of electromagnets to create a rotating magnetic field, which in turn induces an electric current in the rotor to produce motion. Pretty neat, right? Tesla's permanent magnet motor is used in rear-wheel drive setups, while in dual-motor versions of the car, an induction motor is added to the front wheels. Tesla can shift power between these two motors to optimize for efficiency and torque across various driving scenarios. In simple terms, the induction motor is perfect for high-torque situations, like acceleration or climbing hills, while the permanent magnet motor excels at efficiency, especially cruising at highway speeds. But Tesla has also developed a new type of motor for its Plaid vehicles, including the Model S and Model X Plaid, as well as the Tesla Semi. The hairpin motor is an electric motor whose stator winding is done with hairpins instead of round wires. The rectangular shape of hairpins allows for a better fill factor, meaning that the copper winding makes better use of the space, resulting in approximately 20% more efficiency. This technology provides a range of benefits. The better fill factor generates a stronger magnetic field, resulting in a stronger rotation of the rotor and more torque at the wheels. Because the stator can be smaller, energy losses when the electric current goes through the copper, called copper losses, are minimal. This optimized winding path simplifies the assembly process, and hairpin motors have a lower risk of failure in the long term. But that's not all. Hairpins can carry more current than round wires, generating less heat in the winding and in the motor. This simplifies temperature management and improves the reliability and lifespan of the motor. Plus, the symmetrical and solid shape of hairpins makes them easier to wind than round wires. They don't even need stator lacing like round wires, making the assembly process much simpler. With this innovation, Tesla has set the bar high in the world of electric motors. What a time to be alive! Hairpin designs offer numerous benefits over traditional round wire motors, such as precision placement and a cleaner design. That's why companies like Volkswagen, BMW, and General Motors have already jumped on board with this new trend. But implementing hairpin technology isn't without its challenges. One major hurdle is the accuracy of the process of bending and welding the copper hairpins, as even a minor error can cause electrical losses. However, Tesla's custom software has revolutionized the game by modeling and simulating the entire motor along with its rotating electric field, allowing them to quickly iterate through millions of designs to choose the best one. Talk about next-level technology! But what really sets Tesla apart is its commitment to sustainability. They recently announced that the next-generation motor will not use any rare earth metals, which has caused quite a stir in the industry. These rare metals are essential components of the motor and can cost over $100 per kilogram. By eliminating the need for them, Tesla can save hundreds of millions, if not billions of dollars long-term, while also reducing the environmental and social impacts of mining and sourcing these materials. And if you're wondering if this will impact the performance of the motor, the answer is no. In fact, Tesla claims that these new motors will have even higher efficiency and lower costs. This announcement has already caused some shakeups in the market, with rare earth mining stocks taking a hit after Tesla's announcement. But at the end of the day, the biggest benefit for Tesla is that they can scale up production much faster without worrying about sourcing rare materials. And that's a win-win for both Tesla and the environment. And it's thanks to YouTuber Ingenierix that we get to see a closer look at it. First off, let's talk weight. The whole thing weighs in at a solid 194 pounds or 88 kilograms, which isn't too shabby considering all the power it's packing. Speaking of power, this new unit is actually an evolution of the previous drive unit released by Tesla in 2017 for the Model 3. But what sets this new design apart is the all-new inverter, which is much more compact than before and features an all-new chiller assembly. The overall layout is the same, but it's been optimized in many areas to make it easier to manufacture and maybe even prolong its life. However, there's one potential downside to this new design. The cartridge oil filter is no longer user replaceable. But fear not, as Ingenierix points out, it should last the whole lifetime of the vehicle without needing replacement. A smart update in this new design is the breather, which has been moved to the top of the casing. This means that if water ever gets to the drive unit, it can't go inside the gearbox, unless it goes over the breather, of course.